Howdy, welcome to Horticulture Innovators, the podcast series where we will explore impactful innovations in horticulture. I'm Amit Dhingra, your host. I'm a professor and head of the Department of Horticultural Sciences at Texas A&M University. In each episode, we'll explore the inspiring stories of the pioneers who are contributing to sustainability, wellness, and food security through their amazing work in horticulture. Howdy, welcome to another episode of Horticulture Innovators, and today we are really honored to highlight and feature one of the innovators, and he comes to us across the pond, Stephan von Rundstedt. Welcome, and thank you for joining us.
No, thank you very much. Great honor, Amit, for me to be here and speak with you. So thrilled to be part of this.
You know, the world has become a very small place. We are finding that there are innovations happening all around the world. And of course, you and I have been connected online for a very long time. I'm really grateful that you agreed to be part of our podcast because we really wanted to bring the innovation that you and your group and your team has done in the space which is very important, like in the space of micropropagation, but overall in horticulture. And I really wanted to learn a lot about that today in our conversation. So before we get started, I wanted to request you to provide us some background about yourself, about your team, and how did you end up being in horticulture?
That's sometimes I'm asking myself, how could this happen? Actually, it is so that let's start by saying I am the husband of Friederike, my wife, and she's the most important part of this whole thing, simply because everything that we do here is based on a family tradition which has been inherited through the family of my wife.
Okay.
So the background is that I will keep it very short. Wolfgang Bock, the grandfather of my wife, founded a nursery almost next year is going to be 100 years ago, so 1926. And ever since, there has been obviously some kind of innovative spirit in this family. As such, in 1984, my father-in-law founded one of the very first commercial plant tissue culture labs in Europe, with a remarkable size for that period of time. So that grew, of course, and my wife entered in 1995, and I did enter in 1997 the company. My wife, I can say, has a horticultural background. She studied horticultural sciences at the University of Munich by Stephan, and I have, let's say, a business administration background. I think from today's perspective, with almost 30 years in this industry, I would call myself a well-trained layman with great enthusiasm for everything that's related to our business and our industry. But this is how I personally came to become part of this industry. I've been always very, very enthusiastic and really amazed with what is possible here, and how much you can do and how broad as a spectrum this whole industry is. I mean, we've got so many sectors that are covered, from a technological basis to R&D. Molecular breeding. Wherever you look at this is really a very, very broad industry. That's so amazing about it.
Yeah, no, that's great. Thank you so much for that. And you mentioned that there was a nursery that got started 100 years ago. So what type of plants were needed at the time or now that what are all the types of horticultural crops are you working with?
Well, it's actually so that when this was started, it was mainly done to produce food. That's where it started, and then it went to ornamental crops a lot. So even still today in our laboratory that we still run, we do produce ornamental plants. not only, but to some extent. Um, and the ornamental sector became more important, and that's also when the lab was started, because my mother-in-law, when she took over the nursery in the beginning of the 1970s, she then said, okay, we're doing a lot of stuff here. So they were also importing stuff from Italy, because the Wolfgang Borg, the grandfather of my wife, founded two nurseries in the 1950s in Italy, and started exporting mainly cut flowers from Italy to Germany. And my mother-in-law said, okay, it's nice to have a bouquet of flowers, but I like to give the user more of an experience with a living plant. So she started to really look into, all kinds of pot plants. And actually she started to breed in anthuriums and spathiphyllums. So those crops, which were also seen on an, let's say, broad scope, the main crops where tissue culture started with a little bit. And so she's really been breeding very early on in these crops. And I think it's fair to say that still today, bloodlines from her breeding work could be traced back in many of the commercial varieties that are in the market. And since that began with those crops, of course, it was only natural that they were looking into more crops. And then also Phalaenopsis, for instance, Phalaenopsis orchids was a big crop over many, many years for us. In the meantime, we have changed our program quite generally. So we do still work on ornamental crops. We also do some breeding work, but we gave up a lot of that work in favor of the RoBo Tec business that we have been able to create, to set up in the meantime. Yeah. And what we are also actively doing a lot is everything related to trees and bushes and so a lot of different crops that we work with. It's a wide variety.
Wonderful. You mentioned a few things here. You said that you are an experienced layman. I like that term very much. I mean, I think that kind of captures how science is moving, how technology and innovation is moving forward. We're always trying to learn. And one question I had for you is, while you were in a nursery, obviously you multiply chlorally propagated plants, because everybody wants the same types of apples or same type of plantlets to produce the same type of flowers. So you have to multiply that. And when did you transition from the traditional, or maybe as an expert layman for the benefit of everyone, if you don't mind sharing, how were the plants being multiplied previous to your innovation, which we will talk about next as well, as a prelude to what brought you to start thinking, okay, I need to come up with a different method, or your team has to come up with a different method? I would really appreciate that sort of a journey towards the innovation.
I think that's a fair question insofar that it's important to understand really what you say, where we come from. And we came to do what we're doing today in RoBo Tec based on, let's say, pressure. Mm-hmm. So starting with question number one, how was the original way of multiplying plants? So for anybody who's not really known about it, I can just do a very, very quick tour. And it's nothing new to anybody who's doing plants. So excuse me if I'm telling known things, but I try to make it short. We generally have two ways of propagating plants, right? So we have seed-derived varieties, seed-derived plants, and we have also the clonally propagated plants. So it's a generative or the vegetative way. If you're doing lab work, usually, and you want to make a propagation, a clonal propagation, then you go the vegetative way. Vegetative propagation does not mean GMO or anything alike, because that's what people laymen tend to understand. When they hear cloning, they think of GMO, which is wrong, because cloning just means if you have some kind of a plant, you break a twig, you put it into a water, and it builds a root, then you have created a clone, because it just has one parent. And that's the most important thing, because as you said, then you have the genetically identical offsprings, and the generations thereafter, they all remain the same. And that's what you, of course, want to have. If you have, let's say, a certain aspects that you want to follow, you want to be making sure there is a plant that always blooms with the same color at the same point in time, and can be cultivated in a very, very consistent way. And that's where you run into clones and clonal propagation. Some plants are not so easy to propagate, because sometimes it's absolutely enough to create a clone. For instance, take a potato, cut it in half, put it into the soil, and you have cloned a potato plant and made a new one. That's easy possible, but others are hard to propagate on this way. So you are going, you are forced to go another way, and that's when the lab comes into the play. Meaning, you have the requirement for a sterile environment, and the sterile environment is necessary foremost only because you want to make sure that the plant grows better than every fungal spore, every bacteria, and everything else that you don't want to see in your sterile culture. So what you do is, in short, you prepare something from a plant, put it on the growing media, and the growing media has to contain, besides water and agar-agar as a gelling agent, also minerals, salts, hormones, and quite some amount of sugar. Sugar is always attracting every beast that we don't want to see there in the sterile environment. So therefore, we have to make it sterile just to maintain things right, that they will be, that the culture is safe, and that you cultivate your plant and not your fungus, and not any kind of other beast that might be entering your system. So from there, you propagate your plants, and that's now answering the question: where do we come from, and how do we do it? How did we do it? How do we still do it in part? We have sterile hoods. We have people sitting there, and they dress up, so to make sure that they work very, very clean. Usually, you're working with forceps and the scalpel. And then you take out a plant from your jar, which is sterile. You put it on a sterile paper. You look at the plant and you decide on, okay, I have to cut here and here. I want to put this away, and kind of work out the parts, the pieces of the plant that want to be multiplied or mutated or whatever.
That must require a lot of effort, attention to detail. Each plant must have a different requirement. Right. And before you started doing tissue, how long have you been involved in, or your labs or your teams have been doing plant tissue culture, as it is called, as you were explaining? How many years has that been?
Yeah, I mean, it started in 1984.
Oh,
so
wow.
Right now it's more than 40 years. This is, of course, certainly one of the reasons why we have come so far, because we are plant people, plant geeks. And so our driver was always to grow the best possible plant and multiply it in a nice way. So this is where we came from. And the need that we felt was our whole industry, with almost no exemption, speaking of the same, being located somewhere in the Western countries, be it in Europe, be it in USA, has moved production out of Africa, out of America, out of Europe to other countries. So usually a breeding company with own genetics will still maintain, let's say, comparably a small lab to start cultures, but then they are shipped to Africa, South America, India, China, Vietnam, name it. So everywhere where labor is cheap, and let the plants being produced there. This brings along some problems. So you're losing control. You're putting your, let's say, production at risk in many ways. That can be that that you lose things in transit. That can be that your partner lab, your service lab, tells you on the day when the plant are due to arrive that, oh, by chance we didn't have enough workforce and we weren't able to provide you the required and agreed upon numbers, or there was something went wrong in the lab whatsoever. So a lot of things that can go wrong. And based on that, we were thinking of how can we change this? Where's a way to mitigate this problem? Because the problem was at some point in time, either my wife, but especially me, we were just traveling around the world to see the different labs that we were working with, really from South America to India to China and so on. And we were looking for the productions, and this is really exhausting. It's costing a lot of management attention, and you can only have your management attention once, as you know, and if the effectiveness, etc. So we were really kind of tired of that because we saw we were building up things, we were building out nice relationships with customers, and then at the end of the day, things were going wrong for this or that reason. And that was, in the major part, external reasons, which we really couldn't make up for anymore. So that's when we started to look into the question: how can we find a solution to this problem? And one thing that you asked, which I still find also interesting to answer, you said it's obviously a lot of effort connected to producing plants in vitro. Yes, especially because it's a combination of so many things. So you have human labor that you want to make sure that you have enough trained, staying on board, being motivated, not get sick, etc., etc. So all the things that we speak of when we speak of human labor. And then you have a lot of, so that's the trained workforce. Then you also need the specialists on the other hand. So everything related to media formulation, because a plant is not a plant, there's huge differences, and what we call a protocol, which consists of how long is a day, how warm or cold is a plant standing, what kind of media formulation do you use. That's all important as a picture to make an in vitro culture work nicely and reliably.
Well, I understand that pain a little bit because in 2011, I also spun out a micropropagation production spin out from my previous program when I used to be at Washington State University. So I'm quite familiar. But the challenge is that this problem in availability of plant material exists. And your company and your team has really spearheaded a revolution in that sign on the technology. You kind of pioneered that. First of all, I was very surprised to know that you've been doing plant tissue culture on producing plants, fruit crops, ornamentals since 1984. Because what is interesting is the lack of understanding, or I would say appreciation, for how long this technology has supported horticulture industries around the world. Because in the United States, when I was out there trying to work around with this technology, there were questions. Have you seen trees producing fruit from this? Or have you seen trees or plants producing flowers? And, it seems like in Europe, there's the progress is far ahead in terms of acceptability and understanding. Any thoughts on that?
Yeah, no, you're touching a very important point, and actually, it is so that this reluctance in accepting that new technology has been an issue even also here in Europe. So I know that, for instance, when I entered the company, um, our lab was having a fight with one of the customers who claimed that we would have produced plants and we would have um, yeah, induced some weird kind of bacteria into the plant, and for that reason they weren't growing. So a lot of really crazy stuff was fabricated around plant tissue culture. Even though that, I mean, interestingly, nowadays worldwide plant tissue culture is such a growing market. So
Yes.
the compound annual growth rate lies around 8% to 10% worldwide. So, I mean, we see obviously the acceptance right now is much more there. And it's really so that, yeah, plant tissue culture labs are popping up kind of everywhere. You can read it in the news every second week that there's got to be a new lab here or there. So the technology has arrived now, the broad spectrum of production. And we believe that it's going to be much more, maybe we speak about it in a minute,
Yeah.
based on also the availability of technology as we have developed it here.
Well, I think this is a perfect time to really also talk about the technology because we've been teasing about this RoBo Tec. If you don't mind sharing that part, and also it'll be really interesting to see how you took all that massive human operation and you turned it into RoBo Tec PTC. What does it do? What did it, first of all, please define what it is and what all.
Yeah. Yeah, I can say it all started with a totally crazy idea. And it took an immense long time really to get to where we're at the moment. So let's say to jump from today's perspective, we are there. The technology is market ready. First orders in the book. So we're selling now worldwide to different customers our technology. The idea behind it was, as I said, we were really tired and fed up with having to go everywhere and putting the production to different places and still, seeing all things going wrong. And at the end of the day, I mean, that was nothing we were speaking too much about in 2011. But from today's perspective, if you look at clients being flown around the globe, I think of the carbon footprint, that's so dumb crazy. So we don't really want to do this anymore. We shouldn't support this idea too much. So why won't we rather produce on site and have the right method available? Yeah. So based on our experience and kind of triggered by chance, I was visiting some factory and they had a very, very high degree of automation. And that was something that my wife was bugging me all the time, or it's just because she always said, hey, we have to automate this. And I said, no, this is never going to work. This is so complex, it can't work. So then I came home after I saw this, and somehow I said, okay, listen, we got to talk. Let's see how we can start it. And what I did was I was really, as I said, I have no problem with calling myself a layman because this makes yourself open to wanting to learn. So always, keep awake and trying to get new stuff, learn new stuff. I simply called a robot manufacturer and said, hey, this is what we are doing. And I was thinking, couldn't we probably automate that? And then they said, okay, there are these so-called integrators, so specialty machine builders. Here's one address. They are working with our robots. Go to them and talk to them. So we invited that company to see us, and we explained what we're doing. And guess what they said?
What does it say?
They said, "You're totally crazy. This is never going to happen because what you want to do here, that is what the automation industry calls batch size one production. Because usually in automation, you're having million pieces of the same kind.
Yeah.
And you want to automate million pieces of every one piece is one batch of its own. So completely the opposite of what you usually do when you do an automation. So that was in 2011, and so we said, okay, understood, but let's still try something. So we just said, okay, let's look into what can we do. Can we maybe first of all understand what we're doing here, and is there any means where we could perhaps take a part and automate that? So that's how we started. And then we had a first very, very tiny prototype, which would just recognize things on a plate. So objects, brackets, lines, and grasp it somehow and put it somewhere. That was our first little prototype that we were building, I think in 2012 or so. And we followed this whole idea further. We were also able to attract some subsidies for R&D projects, which was super important because, making such an innovation, as we know from today, is, let's say, more than costly. It costs a fortune. We have invested in the meantime medium two-digit €1 million amount into the whole development. But that's how we started. So we really went small and we looked at what can we do. And then time after time, we understood, okay, we can do this, we can do that. Then we were quite early on thinking of how can we tackle this technology in terms of, you cannot really think of two robots doing this ambidextrous work in terms of one robot holds the scalpel and the other one holds forceps, and then this is working like that. Even though that we did one poster, which we went with to some show once, where we mimic exactly that, just in order to say, if anybody, thinks that he should start the same, then we didn't want to say we are working with a laser to cut the plants.
Okay.
Because also that was in theory possible, but there was of course a ton of reluctance on doing this because we were seeing potential problems at every corner of the process. Sure. So you have to make sure first, how is the plant being cut by a laser, and what are the consequences? What is this laser cut doing to the plant? Is it going to destroy it? Is there going to be any kind of maybe toxic fumes coming out? We were really anxious to not do anything wrong, and so that's how we started. Then when you start, you have to make sure, how do I get sample of a laser cut plant in a sterile environment? Yeah. So we developed some special containers together with the laser producers and made sure that they were cutting that in their own environment without opening this kind of container. And then we were looking, how do the plants develop, etc. Long story. And this led to us having a first fully working prototype. So let's say full process of what I described as a workbench workflow in 2015. So that was a machine, a system, as we like to call it, where you have jars with plants which go into the system, where the lids are taken off in an automated way. Then some optics, some vision is looking into the jar and detects a first and the second and the end plant, takes it out, looks at the plant from different perspectives, and decides eventually where to cut. Then something falls down on a sterile conveyor belt, and another robot that detects again what is lying there and takes it up and puts it into a jar. That was in 2015. That's how far. That's as far as we were, but we weren't there. By the way, what we did back then was we had the intention to develop this solely for our own, let's say, better cutting edge in the market. So we thought not really to propagate this whole technology and bring it to more than just for our own use. That was back then. And of course, in the term of such a project, you come, of course, to points where you say, okay, is this still working? So we had some milestones where we said, okay, are we still on the right track, or should we maybe abandon the project because eventually it may never become successful? And that was also in 2015, because then we were working with 2D vision. We did not have any AI. So what we had was a system that was recognizing somehow planks, taking it out somehow, more by chance, honestly, and putting some cut lines through it. And from there, we were able to attract talents over time. So then we had the first mechanical engineer / software developer. And he said, okay, this is feasible, but we have to change to 3D vision. We have to change, we have to change several ways how we do things here. And he eventually developed, also together with some colleagues that we onboarded then over time, the whole thing so far that we came to a point in 2018 where we thought that we were about ready.
Okay.
We thought we were about ready. And that was also so far interesting. We were able to attract financing party that was a big horticultural producer from the States. And of course, our promise and our idea was, okay, we are going to be selling the first systems in 2020 or 21, which, seen from today's perspective, was totally wrong. But we simply didn't know better, and of course we were trusting the experts that we were working with, and so we were asking, are we there? Are we going to be there? And everyone said yes, which was wrong. So eventually, also trying to cut the story not too long, or to make it not too long, it came so that over the time, what we did was we have had the first machine builder who we stopped working with in 2014, I believe. The second one that we worked with, and that he did a wonderful job. But we decided to go with another one, like almost 2.5 years ago, 3 years ago, with good reason, because the project was advancing and the requirements were changing, and you get to understand much better over the time what you really need and what kind of capacities, knowledges, processes there have to be at a machine building partner. So right now we have a wonderful company that we work with where we have both worlds covered. And the one is, it's a specialty machine builder. But based on the fact that we do expect that we will have orders where we have to produce 10, 20, 30 machines or more, this machine builder, who employs 65 people, belongs to a bigger mother, a German world market leader in packaging solutions. So they have everything that we need for serial machine building, plus also the worldwide network of technicians, everything. So many questions are then answered in terms of, you speak with the customer who says, and what if I have a maintenance call? So we can cover that all. That's been an important move actually towards getting this whole thing to a level where we today are really able to answer every single question and check all boxes that customers have.
Wonderful. Well, that's a fascinating journey, and I'm going to just summarize that a little bit. And I have some more questions that have came up. So it's fascinating that you started with just the initial vision scouting and simple movement of the plant material to going up to 3D vision, looking at the plant from all angles, and thereby applying machine learning or artificial intelligence now to be able to take any type of plant and decide where to cut the plant. And I think just to remind our audience here is you have to cut these plants, make those cuttings so that you can propagate those and root them individually to create those clones. It could be for any type of ornamental plant or more importantly, fruit crops, grapes, horticulture crops are mostly clonally propagated unless they're seed propagated. And these are permanent crops too. So you want to make sure that they're of uniform quality. And also, would you agree? I think the basic driver is really to reduce business risk at the end of the day because of the uncertainties that you were talking about earlier.
100%. Yeah, now, there couldn't be more saying it better than that. What we see today is our whole industry, and we like to call it the industry because it's more and more getting such. So it's getting more and more from family-owned structures towards bigger compounds. So we have, we all see the consolidation in our industry, in our businesses. And that's what's happening across the whole plant producing companies. And, as such, of course, as security in terms of or safety that you're able to maintain the program that they're producing in highest quality, on spec, on time. Everything needs to be fitting perfectly, and that's where automation comes really as a great help and support to achieve this goal. Simply because you don't either you don't have access to enough labor, or you can't pay for it anymore, or plus of course with every human worker there comes uncertainties in terms of quality, sterility, consistency, etc. And you resolve all this when you automate the process. Which brings me again to maybe, if you allow me still to elaborate a little bit more on the technology, because it's so important to understand what we're doing there.
Yes.
So a RoBo Cut, as we see it today, which we have in the meantime 3 different models, so we call it Model 1, Model 2, Model S, does in the following things. As I said, you put jars with plants to be worked on into your system. The system itself is under positive pressure. There's a HEPA filter on top of the cell. So everything inside the production cell is really absolutely clean. Then a mechanism opens the lid. Sounds easy. Is not so easy if you go into the details, because our industry likes to save money on every single aspect. So you're using the shittiest, cheapest kind of jars that you can find. And that's sometimes material that is hard to automate. Plus this all jar plastic manufacturer business and industry, especially if it comes to plant tissue culture, has not been so much oriented towards an automatable product. That wasn't important until now. Now it's becoming important. So that's when it starts. Then you have 3D vision looking into the jar, which then deciding on the first and the second and the third plant to take out. I like to say this is as if you go fly above a jungle, and you want to decide on exactly the one tree that you want to pick out. So For a vision system, it's more or less a green field of different shades and shapes. And you have to decide now where to grasp the first plant. If you look, for instance, for a phalaenopsis has a leaf which is standing somehow. So what you're doing, what you have to decide in terms of the automation and the vision is, you want to make sure that you have the X, Y, Z coordinate plus the way how many degrees you have to turn the forceps in order to get to grasp the leaf right. So this part of the soil development has been a super challenge, and the automation industry calls it bin picking process. So picking from some kind of box an object which is very, very irregular, and this is the hard task which we have found a perfect solution for. So we every single jar that we work with is going to leave the machine completely empty. So we don't leave a single plant inside the jar. So then we put it to the chamber, which we call the theater. And what we do there is we turn the plant by 300 degrees. We take several images, and AI then decides on the best possible image, where we want to cut, where we want to start cutting, because it's making a difference whether you have a plant which you are, let's say, if you look at a plant like this, then you say, okay, there's really nothing that I could divide. If I have a plant presented like this, and I know this is all cuttable shoots, then I know this may be the first and best perspective. So we decide first on the best perspective, then we start the process by cutting the plant and cutting off shoot number 1, 2, 3, etc. Maybe we decide that there is going to be another cut possible at 180 degrees or 120 degrees. So we turn the plant again and finish until there's nothing left to cut. And the plants that have been cut with the laser, so the technology is we have a fixed laser beam, and the robot is leading the plants through the laser beam. We do this in a 3D mode, which is totally crazy from a machine building and the algorithms part, something that's never been done before. So we have certainly, as you said, we have spearheaded in many ways technology-wise developments here, and many things that we have developed are really coming out of the R&D niche. So we kind of push them forward to a use case. And so we are doing these 3D cuts because we're really also, we are just cutting, it's also not just a straight line, but we're deciding on the growth lines of the plant. So it's really so that you have a plant, even if, especially if it's a more complex plant, think of a banana or some musa or the Phalaenopsis orchids, just to name two crops that are more complex. Then you cannot really just make a straight cut, but you have to make sure that you follow the natural growth lines, and that's what we're doing. So we induce as less stress as possible to the plant by cutting them the way we do, and it's much better and superior over any kind of scalpel cut that you can think of, because if you know how people are cutting with the scalpel on a in a flow wood, often number one, a scalper, as we like to say, is only sharp once, and that's the first cut. And over the term of hours, it becomes duller and duller. And that is, of course, something that does not happen with a laser cut. That's always sharp. And then, if you look exactly what people are doing, and I think, you may have seen this also when we were working in the plant tissue culture. Sometimes it's not really a cut; it's rather a squeezing thing that they kind of push, scrape things away. So that's a lot of stress to the plants, and that's where we see one of the big advantages of the laser cut, because the laser cut does not harm the tissue, it does not squeeze the plant, so you have a minimum kind of stress. You don't really burn the plant. That's also something people always think of when they hear out laser and it's kind of burning. No, we are evaporating the tissue. And the interesting thing about it is 98% of the whole matter is water.
Yeah.
So we only have a little bit matter that we have that is kind of burning, but the cells that are adjoined to the place where the laser cut itself happens are, because of the fact that there's water and it's a very short moment where the laser cut is going through, it's cooling again. So the tissue itself remains cold. There's only the laser cut, and the plantlet that you cut off remains absolutely stable and is super quality.
That's fascinating. So what's the size of the cut? I mean, a scalpel is pretty, you can say a few millimeters or micrometers, but I believe with laser, you can create a very precise, very fine, maybe even less than a micrometer cut.
That's not quite so. So a laser cut, or let's say a laser beam, if you look at it in magnitude, then we know it's not parallel. The beam doesn't come parallel, but it forms a focal area, and then it widens up again. So what we do, and that's why we're also cutting in this 3D mode, is we're leading the plant always towards the focal area. So we're not only moving the plants in X and Y direction, but also we're making sure that we always stay in the focal area, even if it's a thicker plant material that we work with. And that's where the laser cut, the laser itself has a thickness of maybe a tenth, 2/10 of a millimeter.
Oh, wow. Wow.
So very, very less material that is being taken away.
Yeah.
And of course, the better you put this, the better you reach the focal point, the better the result is, because it's always also the point where the cut goes as fast as possible.
Yeah. Well, one thing listening to you also highlights one of the takeaway message, the perseverance in innovation. And I think that kind of also brings me to my next kind of comment. I mean, there's a lot of precision, a lot of intelligent horticulture where robotics, mechanization, or AI machine learning are coming together. And I think, yes, we've come this far, but I think we are also passing on the baton to the next generation, right? So I have my next set of questions to you, or have you thought about education? How do we train the next generation, not just in the robotics piece, but obviously they have to have an understanding of the horticultural principles as well. And I think this is where the technologies and the knowledge is merging. So I hope you sell enough machines that you can start donating some of these machines to educational institutions to educate students as well. Is that angle available, or is that avenue open?
Yeah, no, absolutely. I mean, what we do on a regular basis, of course, we have an exchange with universities and professors and their students. So we're getting requests for visits. Once in a while, we may be asked to go and hold a lecture or whatever. So that's what we, of course, like to do, because we like to give further our experience, as you say, and that's one thing which I like to point out, which I find is very important about this issue, and that is, if you're driving innovation like that, you have to stay open very much to try to understand everything around your innovation, but make sure that you have all the capacities from different sides together. So in other words, what we have developed here is a joint effort of different capacities that we were able to attract over the time. So this, the best possible talents that we can think of in different fields. So this started, you know, as a journey in terms of, oh, we want to make something for our own. And how do we do this? And suddenly we were having a first software engineer. In the meantime, the team had been built up to 26 people, and the most of the people were software engineers. So at the end of the day, what we can say today is, yes, we have a machine, a system. 80% of the whole development was software. And that's so important to understand. We are living in a world where software is becoming so much more important for anything that you do. So always keep that in mind. So what we did is we combined plant science, which is for one coming out of our own, let's say, personal body here at Bock. But then we also have AI developers. Then we have C++ developers. That's 2 teams.
Yeah.
We have a perfect machine building partner that we work with. And hadn't we been the plant people, then my claim is nobody else would have been able in a comparable setting to come to the result that we have come to, simply because we're coming out of the use case. So we're not a machine builder. So, but we were able to learn so much about the process and everything around it, and get a good understanding of the necessities and the pitfalls and everything that you have to know when you're marketing a technology like that at the end. That right now we're able to provide the technology to third parties, and that's what we decided then. After all, then I think it was in 2019, 18, 19 that we came to think, okay, we believe we should open this technology. We were very anxious at that time because we wanted, of course, to protect the technology. We wanted to make sure that nobody else is going to come and copy it. Because there's people in the market saying, oh, that's over-engineered and too expensive and it's never going to work and we can do better. Where I say, let them come, because we have gone through this and we know what it took to get us to where we are at right now. But back then, our patent attorney told me, listen, you can go and make everything public because your protection is already so good. And right now, I mean, we have more than 50 patents worldwide for the technology to make sure that this is really protected. Because that's important. We have simply invested too much money to not protect it, make sure that we can make it available first and foremost from our own development.
Stephan, I think you will agree, and I have experienced this at least. People who see how tissue culture is done, it is deceptively so simple, yet when you started developing the robot, it really revealed the multiple steps of decision-making, the multiple areas of our brain that works together to really make it happen. I mean, we haven't even touched the media formulation piece, because that's the whole environmental aspect that needs to be standardized. So I had a question. Does RoBo Tec also make media?
No. Actually, we thought about it. I mean, actually, we could come to the point where we say, okay, we could also provide media. But on the other hand, I mean, honestly, there's enough companies out there who are doing that. And who would we be to kind of go and build up a competing business to theirs, especially since we have more than enough to do with what we're doing here. And so far, I think we're better off in focusing on what we're doing here and making sure that is working. That one important thing, for instance, also is, I just want to have that mentioned because it depicts a little bit the complexity. You know, we're using a lot of AI.
Yes.
In order to make this all happen. And it is not so that we would have only, I mean, if you look at what is available in the market in terms of transplanting systems, there's one AI for the outreach process. And the AI is comparably simple. I don't want to belittle this because it's very nice products, no question. But it's just one AI, and it just decides on orientation, position, and pick point. Full stop, that's it. In our systems, we're using up to 20 different AIs for the different processes.
Wow.
So that may make a little bit transparent the complexity of what we have developed here. So it's much more than just, tackling one little problem. We were crazy enough to think that we should find a solution which covers the whole application.
Yeah. Well, hey,
we made it.
Thanks to your craziness, we have a new product that can really solve the problem. Actually, one question I think would be very much interesting to all of us, or answer would be very much interesting, is benchmarking. I mean, how does this compare to human tissue culture? I know once we get tired, our decision-making starts becoming slower. We start taking shortcuts. Of course, a robot doesn't do that. So overall, if the percentages of survival, efficiency, can you comment on that, please?
Absolutely. For one, just to give you a rough number, the latest model that we have, that we're now producing, selling, they can in the outfeed process set up to 2,500 plants ready produced per hour. That's crazy. It's absolutely crazy. It's never been there before. And depending on the crop, this is replacing 8 to 15 operators. Insofar, this is making, of course, very much for a good ROI.
Mm-hmm.
So that's something that we don't have too much of a discussion about generally. So from what was your question again?
My question was, if somebody was, well, first of all, humans can't produce 2,500 plants per hour. The maximum I've seen from whatever work we've done is about 200 plants per hour, and that was an outlier. Usually it's 100, 210, 115 plants per hour of processing time, like a person can do it. But in second hour, that might be even lesser because now the person is tired.
Yes.
And so my question was benchmarking. So let's say a human produces 80% efficiency in terms of what the plant's survival would be, or 70%, depending on the plant, of course. One thing we have to remember, it's not just mechanical processing. The plant has to respond, what stage it is at, what type of plant it is. But I'm not just that's why I said, let's say 75%. Does the robot match that in terms of plant quality and survival?
Thank you. No, this is absolutely not a problem. We do match this, and we generally we're better than that.
Yeah.
As a rule, and of course we have scientific methods and also big scale grower tests where we were able to prove that our system is as good and usually slightly better than humans overall. Plus, of course, the fact, and that's where it comes from, I like to say, imagine the RoBo Cut is your best worker in the best 5 minutes of the year, but 24/7 available.
Yeah.
And I think this is where really the advantage of this automation shows its strength, its absolute strength.
Well, in the bigger picture, this could be applied to forestry. It could be applied to anything because, frankly, as we know, there is a need for reforestation projects around the world, soil reclamation, where you could do plantings of native species that could be mass propagated with this methodology in a shorter period of time. Because I know that if you went through the traditional ways of producing trees, plants through soil-based propagation, or that can take years. Permanent crops can take years that way. So, I of course, this has been a fascinating conversation, and I wanted to really, having led this, as you said, a use case, I wanted to kind of go to that forest level and ask you a question. In your view, as as leaders in the space of horticulture, I mean, where do you see the significance of horticulture itself in our society? Because the reason I ask this question is, as an academic institution, our mission is to really support our industries, support the economy, and in there we obviously prepare the next generation. And we are kind of centered around three topics: sustainability, which includes profitability, foremost. Train the students is the second part, and then also our environment. And then comes wellness, where plants really bring a lot of happiness to people, and health, both mental and physical. You consume your fruits, nuts, and vegetables, or join your friends or a glass of wine. And on the other side, just interacting with ornamental plants has been shown to be very beneficial. In fact, around the pandemic, that became very clear. And finally, food security. And I think you touched upon that. In today's world, if we are doing production elsewhere, it's a big business risk. So having the ability and the infrastructure to do your own production is an important piece as well. So that's where I'm asking, what do you think about horticulture? What is its significance for the society as you see in Europe from your vantage point?
Yeah, I think you already touched the most important parts, and that's where we, I think, have 100% agreement over. Food security is one. I like to quote my wife. My wife likes to say, "Plant more plants."
Yes.
As easy as it is, as true it is. I mean, because what we can do in order to help the world recover and stay a good place is planting more plants, planting more trees, and of course, making sure that we have food-based nutrition available, high quality, payable prices, affordable prices at any place in the world. And that, of course, all is something where we feel that we can, with our technology, contribute to that goal. And it's so far, yes, that's our main driver. So really, we want to make sure that we can, that there's worldwide the possibility to produce tons of plants in best quality, and really making sure people can have a livable basis, a life basis, and a livable basis, both by producing plants, by consuming plants, and by being surrounded by plants. And I mean, there's a plethora of plants that we can think of, be it sugarcane, be it bananas, grapes, woody plants, eucalyptus. I mean, there's so many plants that you can think of and that we already touch now since we have brought this technology to the market, because people are coming to us really from every corner of the world and of our industry to present their plants and ask, oh, can we do this here on the RoBo Cut? And we have never found a no until today. Even with the very, very complex plants, we're able to provide solutions which are better than the human process as it is today.
That's fascinating. I feel like, I wanted to go back to your comment you made earlier that you're crazy to think that this could be possible. And I think I connected with you in 2016 for the first time, because that's when I heard about this technology. And having gone through the pains of scaling up or helping scale up a propagation, micropropagation, sort of a spin out from an academic institution, I obviously realized the pain. So, I mean, hats off to you for really developing this. But I'm sure the crazy person is still inside you. If you had a crystal ball to think about it, what do you think the future of innovation is, or what type of future innovations you can foresee, not just for your platform, but because you really serve a larger industry? What all can change, and where do you think the students can really focus on in the future? Because this is an exciting field. I mean, a lot of innovations have already happened in row crops, right? In terms of you've developed combines to harvest things. Now you can change the genetics over there. I feel that horticulture is ripe for innovations. Sorry for the pun, but I think this is where the money is to be made as well.
Sure. I mean, I think if we speak of our industry where the innovation is important, I think we're very much for sure everything around breeding. And I mean, there's so nice things happening on the breeding world.
Yeah.
We have contact in the meantime to so many breeders who are also looking at our technology and understand, oh, I can use this for my double haploid production or breeding program, because now I have a means to make sure that I have 100% track and traceability of my, whole funnel which I'm producing, to make sure that my candidate plants are really the ones that I started up here, and I'm sure that this is really the same strain. So breeding is one thing. Automation overall in our industry for harvesting, I think this is right now starting, and it's really getting to become feasible from the technology perspective, and also in terms of affordability of the technology. And it's crazy if you think of a greenhouse with tomatoes where you don't even need a light. So at night, robots are just going through the rows and they pick the ripe tomatoes. That's amazing, isn't it?
Yeah.
Plus, I believe personally that vertical farming will play a role. It is something that is still regarded as very, very costly, yes. But in certain cases, I do believe that it will play an important role. I would expect personally that the main innovation in this field will come out of everything around, Saudi Arabia, Qatar, etc. So the Gulf states, because they have enough money to burn, they have renewable energies, so they can really build this whole thing sustainably on solar power, and they have enough local markets to feed with high quality produce. So there's going to be things coming up. I'm quite sure about that one. And overall, I mean, we will see greenhouses having an important role over the next 50 years plus, for sure. But I would expect that more and more kind of high-priced buildings, maybe really without any daylight, will become more and more the norm for producing certain crops.
Well, next what I will say, you might call me crazy, but if we do colonize Mars, we will need a robot to produce massive amount of plants to colonize as well. So hopefully your machine is ready for space travel as well. But I just wanted to congratulate you and your team and thank you from the community who propagates and horticultural community. What you've developed is really transformative for the industry, but also for the generation to come as well. Thank you very much for your time today, Stephan.
No, thank you so much. Great fun speaking with you. Thank you so much, and shout out to everybody in our industry. Whenever there's something that you need to know, just call me. I'm always just a click away. We're happy to share that with everybody.
Wonderful. Thank you so much.
Okay. Take care.
Thank you. Yes.
Thank you.
We hope you enjoyed this episode of Horticultural Innovators. Subscribe if you want to learn more and spread the good word. Thanks and giga.